Back, it's been 35 years ago, I built my first one of these, what I call a manta ray. It's a submarine, but it flies like an airplane underwater. Has two motors that I can tilt up and down for pitch and roll right and left. And I can control the speed of the engines differentially and get yaw. And 35 years ago, it worked well enough that for the last 35 years, about every 3 or 4 years, I try to make one that works. And the biggest trouble has been communication, but hopefully I've solved part of the communication to at least get me moving. Okay. When I first tried it, I put it in a fiberglass pool, had an RC connection, I believe probably on 50 megahertz. I was on the ham bands then. And it kind of worked. In a fiberglass pool. Shortly after that, I moved. The only pool I had access to was a gunite pool with rebar. And, well, I had no communications. I even put a 10-watt amplifier on my transmitter. And if it would get down lay on the bottom, well, then that was the end of it. This frustration finally, after this is probably my 7th revision, I thought about everybody. Big talk now on drones is fiber optic drones. So I thought, let's try that. And I got some sensors from the Toslink, which is used on audio equipment to communicate between boxes. I basically used Toslink sensors, a receiver in the submarine and a transmitter that I built a little module that takes the trainer cord signal. So any trainer cord, most trainer cord signals are the same. It's a positive pulse that goes negative, spaced by the spacing of each channel, about 1.5 milliseconds. Anyway, the if you turn it on, you can probably even see the.
Welcome to HTX.
You can see. You can't see it. I can see it, but the camera can't see it. Anyway, you can see the red light coming out of there. Yeah. Well, that's how we're communicating. All the mixing and so forth, of course, is done in the radio. So it's just a matter of a small microprocessor in here converting the data that's coming in to move the two servos that are, this is an older one, sit off in the wingtips. And this is a plug. I found the best access without taping it. And there's all kinds of ways of doing it. RC boat. Some of them they'll put a hatch and then they'll tape the hatch shut with some special tape. But I found that it's about a 60 millimeter O-ring and print a hatch. And this goes in there, and it seals good. I've not had any trouble. No leaks here. Leaks everywhere else. Leaks like a sieve. And I find those leaks by I take this test set, put it underwater, and blow lightly. It only takes a few pounds of pressure. Even at 10 feet down, you only got 4 pounds of pressure. So you blow lightly and you put it underwater, and you can see where the leaks are, and you fix them. So it's not hard to make it more or less watertight. You're going to get some seepage, especially if you're. The first few I molded out of fiberglass. I had a really nice watertight structure, but that takes too long. So now I print them. This is PLA, I believe. And then try to seal it up as best I can. Anyway, that's the basic gist of the whole thing. The fiber optic, which here you can see it's 1 millimeter. It's a plastic. I don't know what that is. If it's an acrylic, but I found that the outdoor light would interfere with the receiver. So I coated it with a rubber coating, and that kind of solved that part of it. The amazing thing is trying to make this sync. you got to really work at it to make it small enough that it'll sink. This is about 160 millimeters square, and pretty compact. I mean, it weighs about 14 ounces, I believe, but 2 of the ounces are a lead piece that I had to make and put up in the front to balance it out and get it to sink, you know. So there's a little. Normally I fly with a cover, with an acrylic cover, so I can look in there and see if I've got water. You know, and if any water seeps in, I usually put some paper towels in there, and it'll any seepage, it'll soak it up and won't get back on the electronics. You see a little stamped computer back in there, and then the toss leak sensor plugs in here, and over here I got a little voltage converter, converts the 4-cell LiPo that I'm using, and gets it down to the 5 volts necessary for the servos and the computer. I originally used NiCads because of the weight. I figured they're heavier and the charger's simpler. Don't have to have a special charger, you know, if I want to give one to the kids. But I ended up buying these Mabuchi motors, which seem to work really well. They're they work up to about 18 volts. So a 4-cell LiPo drives these just about right. The speed is fairly good, not too bad. I'm happy with that. And I just had to add a couple of FETs to the board to drive the. I pulse the FETs to drive the motors, and then of course the computer puts out the servo signal to run the servos. You know. Anyway. Okay, let's throw this in the water and see what happens. I've got a drone hovering over the top of the pool to hopefully catch some video here. When I first throw it in, I stretch out the line, get it all the way out, and then I start coming around and start flying. It takes a while to learn depth and stuff. It's a little hard to tell if you're a foot above the bottom or right on the bottom or whatever. There's an outside loop. Let's see here, a little bit of a roll. You know, as you can see, it pulls that line around without any trouble. You know, hammerhead. I try to do, and I never do it. I try to turn as many turns to the right as to the left, and I don't. And I didn't realize, but as I watch these videos, I find that I'm turning to the left most of the time. So I guess it must be Coriolis force is causing that, but whatever. But it for some reason, another roll. For some reason, it does an outside loop much easier than an inside loop, and I don't know why. And it does it with no correction. A regular loop, it has a tendency to roll one way. You know, see, there was an outside, and it just pretty much stayed straight. You know. But I've gotten it, get it in deep water and come up and do a vertical roll and come down to a roll going straight down, and it's got all of the capabilities of like an indoor airplane. You know, if you've flown the little F-3P airplanes that only weigh 20 grams or I don't know what they weigh. They're very, very, very light. They're not really flying. I don't think they're flying. They're swimming. You know, they take so little angle of attack to disturb the air to keep that very, very light aircraft in the air. Why, I don't consider those flying, and this is not flying. Guess what? It's swimming. Can you believe that? Here I put a camera under the water to get a different viewpoint, but I don't know. I was trying to fly near the camera, and then it turns out I wasn't really in the camera all the time. I was too close. So there's a bounce roll off the bottom. That was kind of nice. I don't know if it was flying pretty good today or not. You know, this has been over about 2-week process of I've been piddling with this thing. So I'm about ready to park it. I'm going to do some different types of communication. I'm going to use maybe a pair of twisted wire, RS485, and maybe able to get a lighter wire and something that the acrylic and the fiber optic, it tangles real easy, it kinks, it breaks. It's not a reliable method for this kind of horsing around, So I'm going to have to go to do something else. And in the long term, I've built I'm going to try to communicate with them using ultrasonics. I took a circuit from a ultrasonic cleaner, and I've got a transducer, and I've got it mounted on a plate. I'm going to throw that in the water, and we're going to try to make some means of communicating with the drone without wires through ultrasonics. And I think it's possible. I don't know if I'm capable of doing it, but we'll piddle with it for a while. The circuit's all done. I just haven't sat down and got all the programming done. So anyway, but it's fun to fly. Maybe if somebody has interest in it down the road, why I'll maybe put together the plans, I guess, more or less, 3D files and so forth, and basically how to put it together. I can't seem to keep hitting the bottom today, but it tolerates that pretty well. It's built. The PLA is built with 2 millimeter skin thickness. I draw it in Fusion and then hollow it out. And that's how I create this. And then the wingtips are just glued on with silicone glue. So if a servo gives out, gets wet or whatever, why it's a matter of just taking a penknife and cutting the wingtip off and putting in a new servo and then taking silicone glue. I was playing with taking off, seeing if it'll land and take off from the bottom, and the props have enough clearance that they aren't hitting, and it finally gains enough speed. It gets enough ability to get enough uplift to get off the bottom. I don't know if it's getting water between the bottom and the frame that causes it to go up, or if it's engines doing it. But anyway, there's a whifferdale. Anyway, hope you enjoyed it. Thanks for watching. Bye.